Alright, so today it's day 54. I'm gonna show what I did. Today was mostly about deep code also. Um, I finished all array and hashing and two pointers. I think we are at a good pace given that I started like three days ago, I think. And we already completed like the first two parts. And what problems I did today? Today I did this one, container with most trap water. The intuition for this one, this is my code. What I did was essentially I realized that like you can start one pointer at the beginning, another pointer at the end, and you can move the smaller pointer. And before moving the smaller pointer, you can compute like the amount of water there is, and you keep like the highest possible amount of water, and that's like the whole intuition. So I like abstracted like the computation in another like outside as a function, and I do what I said, that it's like given the two pointers, you compute the water, um, keep the maximum value between the current and the global maximum, and move the smaller pointer. If the height this one is less than j, it means that you have to move the smaller is the left one, so you move the left one. And you have to also update the width because it changes, which is very similar to the code implemented like in the solution, but I think it's there are a couple of things which are different. And then the other one, the trapping rainwater, this one was definitely much harder. I had a couple of mistakes in this one, but the solution is you start again with two pointers, one at the beginning, another one with the end, and you do like the standard condition two pointers, that while the two pointers do not meet in the middle, you're gonna check. The way to tackle this problem is to think about it as if you have two walls, right? And you're gonna try to know which are like the limiting value of the wall. So you start a pointer here and a pointer here, let's say, and then you do the same intuition. You decide which pointer to move, and you're gonna move like the smallest with the smallest height. And then if you move this one, the problem I encounter is that you cannot set this amount of water like you have to have like an anchor, like some type of wall, because what I did, my first approach was to say like every time I move a pointer, I compute like the possibility, like the amount of water like that possible cell can give. So for example, if I have a first pointer that has height 1 and another one that has height 2, it means that the maximum trap water that the left pointer that I'm gonna move to the right is gonna be 1. So you put here 1, and then let's say you move again the smallest value, you get this one, and then both pointers have height of 2, so the maximum trap water is 2. So you have to think about it. When I move the next pointer, the maximum amount of trap water is gonna be 2, and the next height is 1. So the trap water is gonna be 2 minus 1. And in theory it works, but the problem is when you get like to this I don't know, like to this vacuum, because the maximum amount of water is 2, the height is 0, is 2 minus 0, yes. But then the problem is that it depends if the previous one, like it's to respect to the wall, and the wall is marked in this pointer. So you gotta keep track of the wall, essentially. That's like the intuition. And I think I explained it like really bad, but I think it shouldn't. I mean, it's not that hard. It's like you have like two walls, left and right, and you can move the pointer, and the wall can still remain. And that's it. And you moved like the smallest pointer. That's it. And for what else? And I also did this one, the encode decode. And for the encode decode of strings, essentially for encoding you need to save the sizes, and then when you decode like you save the sizes and then you save the words. So once you do the decoding you can say you get the sizes again and you set like a condition while you do not meet like a hashtag or like a special character, you're gonna get sizes, and each sizes is gonna be delimited by a comma or something. And then once you have the sizes you can get all the words by kind of list, like a list slicing, and that's basically it. So we finished this, or until now we finished 14 problems. We're gonna continue, but that's it for today.